Now we do have a former colleague of mine that is now moved on to Red Hat, and it's Alex Menezes. He's a service reliability engineer at Red Hat. And today he brings us an awesome talk that is a case study on values of operators. And from that point on, I'll let Alex take it on.
Hello, everyone. Welcome to the Cloud Native Day. So my name is Alexandre Menezes. I am a service reliability engineer working for Red Hat, helping clients and partners to develop their Kubernetes operators. Thank you for tuning in. And today we have a talk on the value of Kubernetes operators, which will have basically 4 questions in our agenda, which are: what are Kubernetes operators? How can we quickly develop an operator? How far can we go with operators? And how can we package and distribute applications with operators? So without further ado, let's take a look on that definition. What are Kubernetes operators? So a classic definition that we find on the community, we can find easily on community repos, is something like that. An operator is a method of packaging, deploying, and managing Kubernetes applications by taking human operational knowledge and encoding it into software, right? But let's try to translate that into simple words. How could we define Kubernetes operators in simple words? Operators are nothing more than a deployment. It is another deployment that we run inside our Kubernetes cluster, right? It has a special controller, and that controller is nothing else than a loop that will be doing a few things. One is watching your application, and 2 is reconciling your application to its desired state. And how does that controller do that? It needs that your application be modeled into a custom resource definition or a custom resource inside the Kubernetes API, extending the Kubernetes API. So the same way you have objects like deployments, daemon sets, or stateful sets, you may have your application name, whatever it is. Like, let's say that we have an application called Cloud Native application. So then we would have a type or a kind called Cloud Native inside the cluster because you built that new type using a custom resource definition. So this controller will be basically watching that custom resource for you. Not only the primary resource that we call that main custom resource, but all the owned secondary resources that your application may own. What does that mean? It means that your application may own deployments, daemon sets, stateful sets, secrets, config maps, whatever you want to use to make your architecture or the architecture of your application work well. So that said, what can be under my custom resource, right? What kind of objects can be under my custom resource? Let's take a look on that. Let's imagine that you have a web application. To be a very simple in the beginning, let's imagine that you have a web application, right? So you're beginning to plan. You have those things. You make a design, and then once you have that, you begin to go towards more coding and then begin to make your architecture, front end, back end, language choices, database choices, and then you begin to play with containers. Podman, Buda, maybe Docker, maybe Docker files or shell scripts to build your containers and artifacts. And finally, you get a pretty good idea on how your microservices will work together. And then you come up with a design that is pretty simple like this: a web server, a database, some storage layer, and you begin to think about clusters. When you think about clusters, you begin, am I going to run vanilla Kubernetes? Am I going to run OpenShift? Am I going to run a managed Kubernetes on top of public cloud environments? That's a question that you need to answer. But once you have it, you finally begin to have fun with Kubernetes manifests, right? And when you begin to have fun with that, depending on how complex your application is, let's take a look on this cloud native application. So it may have multiple layers, and it may have multiple replicas. So then you begin to think, okay, now I need a namespace to better segregate my application. I need some resources for my front-end layer, maybe deployment, secrets, ingress controllers, ingress configurations, service meshes if you want to go fancier. And then you go to your database layer and begin to think, okay, I need some secrets, maybe some config maps. I need to make them kind of stateful. So stateful sets will be a good choice. And then you need some storage classes and persistent volume claims. We'll do the dynamic part of it. So a lot of resources are being mentioned here. And finally, you need to choose some service accounts, some role bindings to make all this cloud native application run on top of your cluster. But what if your application is not exactly a web server? What if you're writing something low level, like a networking automation that is trying to deal with a special network interface cards, or like a storage plugin, for example? Your operator is dealing with external storage, with external storage drivers and things like that. Or let's say that you are dealing with machine learning and you want to deal with special GPUs that need some kernel modules. You may need to think about tuning your Kubernetes nodes, right? And when you think about that, things get a little bit trickier, because you may want to tune in a little bit to move some knobs in your Kube API server configuration, for example. You may want to put network policies if you're dealing with multi-tenancy. You may need an in-cluster image registry. You may be dealing with storage plugins. So no tuning goes far away. You may need some kernel modifications, and you're certainly going to be concerned about the whole aspects of authentication, certificate authority, security context constraints, or pod security policies in the vanilla Kubernetes, cluster monitoring, and auditing. With that, you have a lot of things to worry about on your nodes if you're dealing with more low-level stuff. So if we go a little bit further, how about your cloud environment? You may have region A, region B, a public cloud provider, and then you begin to think about, how about my virtual networks? Am I doing something different there? Are my external load balancers enough? Or do I need to tune something? Security groups, virtual firewalls. Do I have dedicated connections? Am I connecting to a data center on-prem? So how about billing? How about data replication? How about DNS, backup, key management, system accounts, gateways? So things can get a lot trickier when you're dealing with the base infrastructure, but you can still go further if you have a private cloud. And then you may be dealing with routes, context firewalls, VRFs, VXLANs, tunnels, internal load balancing. You may have some net rules. You may be dealing with SDN or SDS. You may be running on top of OpenStack. So a lot more APIs to deal with, a lot more resources to deal with, depending on how far you are in terms of application and how specialized your application is. And that would be your private cloud or your on-prem data center. And this could be your hybrid cloud. So once we get here, there's definitely a lot to discuss, but operators can touch all of those parts with more or less flexibility. And you may develop operators specialized in a few pieces. You may put operators depending on each other, but all of that can be part of a custom resource of some sort, right? So just to give you an example on how all of that can be used, and I think it's a very good example, is when we look at, for example, the OpenShift cluster. So if we run, for example, OC get cluster operators, well, we'll get a big list of operators, and they are taking care of multiple custom resources that we have inside inside OpenShift. So for example, if I want to take a look on how my Kube API server is configured, I can easily come here and say OC get Kube API server. I have an object, an instance of the Kube API server that is a kind that is called cluster. And I can actually get Kube API server cluster and take a look with -o YAML and see how it looks like, right? So this would be the whole Kube API server object with all its fields, with its spec field, metadata, everything that you should expect on a Kubernetes object with status messages and all the details, right? So if you try something like, let's say, network, for example, I could say that, like OC get network, and right away I have a network object called cluster, which I can also inspect the same way. So let's take a look. Same thing. So how is my network? What kind of prefixes am I using? For example, like my general CIDR, my service network, what kind of network plugins I'm using, and things like that, right? So OpenShift makes a very, very good use of operators in that case. And those operators are basically cluster operators. So they are not applications being served to clients, but rather they are actually managing Kubernetes concerns. That's the idea behind having your nodes and node concerns being taken care of by operators. Since OpenShift is an operator-centric Kubernetes distribution, you will have a lot of those to facilitate your day-to-day work. Once we understand that our application needs a custom resource to represent it, and that an operator is nothing more than a deployment that has a controller that will be watching that resource, and also its secondary resources, the resources that your application owns. So all resources like deployments, daemon sets, secrets, anything you want to manage for that application. Once we understand that, we can take a look at the operator SDK, which answers the question, how can I quickly develop my first operator, right? So this is nothing else but a tool that generates code for you to quickly ramp up with developing operators. Let's take a look on the operator SDK in action. Operator SDK. Here I'm going to create a new project, right? So I have it already installed. So I'm going to create that application. Let's say that I'm managing an application called Cloud Native. Okay. So and then I'll have a Cloud Native operator that will manage that application. With that, I create a project. It will scaffold everything needed inside the projects folder. Then I go in to the projects folder. I need to add those two important pieces that we've just seen. So I need to add an API or a custom resource. I have the parameters already here. So I'm creating both the API code and the CRDs with the new kind called Cloud Native. It will generate the code inside of the projects folder. And we see that it generates CRD, it's one file, and the API code. Okay, so once I do that, I need the second part of the game, which is a controller. I need to add a controller. So controller is the part that will hold the logic, right? So add controller, same parameters because I'm dealing with the same application, same version and same kind. So it generates the controller code. After that, we can check if we have what we need here. So let me take a look here. So we have the build folder. Once we need to build our operator container, we have the CMD that has the main file for the project. We have the deploy folder, and here we can find the CRDs and finally the CRD file that we need to deploy that kind to the cluster. On the package folder, we have the place where the magic happens, where the APIs will live and the controller will live. So once we have all of that in place, I can go. I have an OpenShift cluster running here, so OC apply, pretty much the same as Kubernetes. OC apply -f, and I'm going to that deploy CRDs, and I'm going to deploy the CRD. It's a CRD file, a regular one. So now we have a new kind. I could try to say OC get cloud native, which is the name of my, and instead of saying that the kind doesn't exist, it just says there's no resources in this namespace of that kind. So the kind is already there, right? After that, I can go and say operator-sdk run local. It comes embedded with a very simple CRD that manages one pod, but still we can look as an example. Let's take a look. Quickly bring the other terminal here, because now it's running as a loop from my laptop, so I can stop this part on the top, and then I can come back here and say, okay, now let me deploy. If I do OC get pods, I have nothing as well, right? No pods. Okay, I need to export my kubeconfig. Let's quickly do that. Config file or OC get pods. No resources, right? So now I can try to deploy OC apply -f. The example CR that comes with, it just first need to come in. Okay, so OC apply the example CR, which will be here on CRDs, and instead of going for the CRD, I'm going for the CR file. So, and then I can deploy. Immediately the operator will react here, and now we have OC get pods, and the pod is running for my application, and I can say OC get cloud native, which is my application, and then we have an example of the cloud native application deployed. So, as I said before, the magic happens inside the package folder. Here you will have your types and versions, right? But the logic will be inside the cloud native controller.go. So here we have all the functions needed. First, to watch the resources that we need to watch. The primary one, that is the cloud native resource. The secondary one, which in this case is just a simple pod, and we reconcile using the reconciler function both the primary object and also the secondary object, bringing a new pod instance if necessary, if it is not there yet, to our application. And that pod is defined on a separate function here, new pod for CR, that has a syntax that's pretty much like an YAML file, right? It is the way Golang defines objects. So here is where you can have the logic for all kinds of objects that you need. You may watch anything here on the top of the code, whatever you want, daemon sets, everything that we showed on the diagrams. You may watch anything here and then reconcile them inside the reconciler using functions like that to define, to declare the state that you want your objects to run. And if you have the proper credentials, you can go outside the cluster and talk to objects, to appliances, to anything you need on your infrastructure, on your base infrastructure as well, which will certainly impose some complexities, but it's a full-featured language. You can do anything you want with that. So this is a quick rundown on the operator SDK. Of course, there is a lot more to see. Finally, after this quick rundown on the operator SDK, I should say check it out. Definitely, it has a lot of features that we didn't explore here. So operator SDK help can give you kind of a sense of what it can do. So apart from adding your APIs and your controllers and creating new projects, it can build your operator with multiple options. It can also help you build your packaging for operator lifecycle manager, which is another piece of the game. You can run all sorts of tests. You can run locally your operator with multiple options as well. So there is a lot of things you can do here, right? So from this point on, the next question would be, how far can we go with operators? So this picture is around for quite some time, and you will find this on the community projects. You will find this on blog posts. You find this at the OpenShift documentation, for example, when it talks about operators. And for sure, you see those two different pictures here, Helm and Ansible. Yes, Operator SDK also can work with Helm and Ansible. So if you already have Helm projects and Ansible projects that you want to accommodate inside an operator, Operator SDK can help you do that. So just be aware that Helm won't go too far. It will stay kind of in phase one, just installing things and deploying things. Ansible can go very far, but still it is a layered approach. So if you are, for example, calling multiple scripts with multiple languages, it won't be that easy to manage as if you do a Golang operator that will be running natively inside of a Kubernetes object and seeing everything from one point of view, which would be the Golang code, right? So once we look at those phases here, we can see that we can go very, very far. So normally we begin developing an operator just by collecting the resources that we need for that application to run, as we saw on that big picture with many tags. What do we need for our application? Then we begin deploying those objects as secondary objects that are owned by the bigger one, which is the one that represents your application, the custom resource. And once we do that, we begin to install things. Okay, now I may think about, what if I upgrade to a new version? When I upgrade to a new version, I can code a logic to do seamless upgrades. So it's an application that is aware it's being upgraded, so it can take care of multiple things and upgrade on the fly without dropping your clients, for example, right? Once you have that, you can step a little bit further and then think about all the routines, all the tasks that you may have to do, like cleaning indexes, backing up, restoring things, failure recovery, restarts, whatever you need to recycle the application and keep it sane, keep it working correctly for everyone. Once you have that, I would say, operational toil done, Operator SDK will also help you with deep insights, because it already has built-in a metric, let's say a metric instrumentation to collect metrics from your applications. So once you have the metrics, you can build also inside the operator logic to interpret those metrics, create alerts, log, process everything that you need, and put it out to a dashboard, for example, and do certain analysis. If you have that intelligence in place, then comes the time that you can see, okay, I think I need to do horizontal auto scaling. I think I need to do vertical auto scaling. I can't fine tune my application. So, and all of that in an autopilot mode by taking action on top of the deep insights that the operator is retrieving from. And we finally get to the point where we gotta ask, how can I package and distribute my applications using operators? So the answer is definitely the operator lifecycle manager that has a lot of features to take care of your operator versioning. It helps you with upgrades. It helps you pre-installing CRDs and artifacts that your operator will use. And to jump right in, I can show to you how it's done in a very quick way. So here we have the operator framework, community operators repository. So inside this, we have two folders, community operators and upstream community operators. This one is for Kubernetes and this one is for OpenShift. So they are pretty similar and they're using what we call metadata bundles. So I'm going to pick up as an example here the Argo CD operator, which is developed by one of my teammates, just to show you how a bundle, a metadata bundle looks like. So this is what you will see with the versions. And inside those versions, you have a very important file called cluster service version. And here you can completely describe your operator in every sense, like the owned objects, what kind of custom resource definitions you were using. You can even describe like UI functions that you want to use if you are showing your operator up in the UI. So from this repo, from the community operators repo, is where you can actually contribute with your operator metadata bundle. You can have something like this, which is the operator hub IO, where you can browse all the operators. You can filter here by category. You can find a specific level operator. And also you can do that inside OpenShift. So this is the OpenShift operator hub, the same experience you're going to have here. It is embedded inside OpenShift. And I already installed the Kafka, the StreamZ Kafka operator, just as an example. It is already installed, so I can see a lot of information here already, and then I can view the installed operator here. So in the installed operators window, you can see which CRDs, which APIs, which custom objects it is managing. So for the sake of an example, I have the Kafka cluster installed. So here I can see the Kafka cluster. I could create one using a YAML file that is actually representing that CRD, or using a fancy form that is also defined on that cluster service version file. And I can as well, I can see when I click inside, when I look inside the cluster, the CR that I'm looking at, I can see the secondary resources that the operator is managing on behalf of that application. So you can see a giant list here with a lot of secondary resources. So all those pods, secrets, deployments, replica sets, stateful sets, everything is being managed by the operator, and you can see the status here in this screen. And everything happens in the UI here in OpenShift. In Kubernetes, you don't have this fancy UI, but you can do everything by the command line. You have subscriptions for your operators, you have install plans for your operators, you have also packages that you can list to see what operators are available, and thus what applications are available as well. And then we need to ask ourselves what we can get from all of that. So how cloud native is that, and how much value are we extracting from operators? So you'll tell me, take a look at the cloud native definition, and you'll see that operators they are touching build and run scalable applications, public, private, and hybrid clouds. It is using declarative APIs everywhere. It is definitely resilient, manageable, observable, probably the most robust automation pattern that we'll see outside, and for sure it will reduce a lot all kinds of maintenance needs that your application has. So definitely it is a cloud native technology. Apart from that, what I can say, I hope this was informative for you. That's all I've got for today. Thank you very much for watching.
Hi, Alex. So thank you very much for this awesome talk. Is Alex online?
Yes, I am. Can you hear me?
Oh, we can hear you. Awesome. Thank you,
Cool.
Alex. This was an excellent talk. Really appreciate it. Hope everyone also liked and enjoyed the talk that you just provided everyone. I do have 2 questions for you, Alex, if it's okay.
Okay.
The first question is, what would be the first step for someone that would like to start writing his own operator? Is it the operator SDK, or what tip could you provide those persons?
Yeah, I guess the operator SDK is the way to go because it cuts a lot of the work and understanding the Kubernetes API and all the, you have a pretty well organized generated code where you can put your logic inside. Of course, you need to have an application, right? In order to manage use an operator to manage that application. But operator-sdk is for sure the fastest way to develop. So I think the website is pretty cool, has a lot of documentation. We're working on new material on that too. So yeah, I think is the way to go.
Perfect. Thank you. And another question that we do have is it fair to say that operators can bring a business logic into your deployments compared to other packaging services?
A business logic.
Like, what would be the main difference for someone that is mainly used to use Helm? Why would he go away from Helm and use operators? Because you could bring more to the deployment of your application?
Yeah.
Or
I got it. Well, I wouldn't say business logic. I would go more with operational logic, because like Helm, what Helm does is it creates a really well packaged structure to deploy your application with its various artifacts. And you can version that using Helm, but you stop at the deployment. You stop at updating maybe, but you can go further. So with the operator, you can actually put a lot of intelligence on top of that. You can check the status of your application in many senses, and from there you can actually put even artificial intelligence if you wish, and make your operator react to changes in your application. You could, for example, build intelligence to understand what your application needs, or to understand the baseline metrics for some sort of KPIs that you are observing there. And then if you want, you can take action upon that. So the operators go way far than simply installing and updating or upgrading your application.
Perfect. Awesome. Thank you for clarifying this point, Alex. So those are the last questions that I have. So once again, Alex from Red Hat, thank you again for presenting this awesome talk, and have yourself a great day.